So the main goal today is to understand Kirchhoff's law, Kirchhoff's current law. The current entered in the system is equal to current exit in the system. All right. So Kirchhoff's law. What does Kirchhoff's current law tells us? Current enter is equal to current exit. Here I have one junction. When I talk about junction, what I talk about? I have a diagram A, I have a diagram B. In diagram A, I have 10 volt, I have 2 ohms, I have 10 volt, I have 2 ohms, I have 4 ohms, right? Okay. Diagram A, how many junction we have? 0. Diagram B, how many junction we have? Okay, so we have 1 and 2 junction. Junction 1 and junction 2. So then what junction means? Junction means like if you're a driver. If you are a driver, then you have more than one path. So for charges at junction, charge can take either this direction or this direction. The charge has option. That's junction. In this case, I have only one junction. Okay, so all right, let's see. So this is 7A. Is the current entering or exiting? Of course, entering. So if the current entering, so you want to write it over here, 7A. 5A. Is the current entering or exiting? Of course, current entering. So the current enter is 12. Is the current entering or exiting? Current exiting. How much? 3A plus X. Okay, so 3A plus X has to be equal to 12. So X has to be 9. So this one has to be 9. So that means the current entering is equal to current exiting. And that's the Kirchhoff's current law. Let me give you another example. This example, I'm going to make it 2 junction. All right. So 2 junction. Instead of 1 junction, I'm going to give you 2 junction. So I give you 2 junctions. Junction 1, you have, if you are a charge, you have 2 options. Either go this direction or this direction. Over here, charge has 2 options. Either go this direction, this direction. That makes it 2 junction. Okay, now, if I give you 2 amps, right? Entering or exiting? Current enter is equal to current exit. So current exit enter is how much? 2A. Current exit has to be 2A. All right, so this one is 0.67A. Okay. All right, so that 0.67A. So 2A is equal to 0.67A? Absolutely not. So how much current exiting in this direction? Of course, 1.37. Or 1.33 rather. Okay, so that makes it current entering is equal to current exiting. Okay, great. Now, junction 2, if you look at junction 2, then what do you see? At junction 2 takes how much current? Well, 133. 1.33A. If you don't see point, make it visible. And if the current exiting is 0.67, then current exiting has to be also 0.66. So that. So together, 0.67 plus 0.66 give you 1.33. Okay, so where this come from? This is a snapshot of a bigger circuit. Is this a circuit? No. So what is this? Snapshot. I took a big circuit, I cut it a slice, and this is a slice. This is a snapshot. So let's take a look at the bigger circuit. If you have to see the bigger circuit, this is that's it. This is 84 volt, and this is, let's say, 30 ohms. Let's say this is 6 ohms. Let's say this is also 6 ohms. Let's say this is 5 ohms. This is 5 ohms. This is 12 ohms. Let's say 10 ohms. Okay. 1, 2, 3, 4, 5, 6. How many bulb I have? I have 6 bulbs. How many junction I have? 1, 2, 3, 4 junction. Okay. Now, I'm going to convert this one to a simple circuit. How can I do that? So, and this is 84 volt. This is 30 ohms. This is 6 ohms. This is also 6 ohms. It's getting too crowded, so I'm going to make some space over here. So this is 84 volt. This is 6. This is 30 ohms. This is 6 ohms. This is 6 ohms. This is 10 ohms. So far everything is right. Now I'm going to add this 3 plus 3, which is 6. Let's call it 3 plus 3. 3 and 3. So I'm going to make it 3 plus 3 is 6. So this one is equivalent to this one. Okay, they are the same. This one has 6 bulb. This one has 3, 4, 5, 6, and this one has 5 bulb. Now we're going to call it diagram 2, diagram 3. 84 volt, 30 ohms, and then we're going to add 10 ohms. We're going to add this 3. If you add this 3, that's 2 ohms. Okay, great. And now we're going to go to the last diagram. This is 84 volt, and add them up, you get 42. All right, now you're going to find the current. So what is the current over here? Ohm's law tells us the current. Current is V over R. V is 84. 84 divided by 42, which is 2. So the current is 2 amps. Now 42 come from 30 plus 10 plus 2. 30 plus 10 plus 2 is in series relationship. The series relationship, which is true, the current is same. So you're going to write the current 2 amps, 2 amps, 2 amps. 30 times 2 is 60 volt. Okay, 4 volt and 20 volt. Okay, great. So now where does this 2 come from? This 2 come from 6 plus 6 plus 6. Ohm's law tells us that is 2. 6, 6, 6 in what relationship? Parallel relationship. What is 2 for parallel relationship? Voltage is the same. What is the voltage? 4. So you're going to write 4 volt, 4 volt, and 4 volt. Okay, now we're going to try to find the current. The current is, of course, voltage over resistance, so 0.67. So 0.67 and 0.67. Okay, now we have the voltage, we have the resistance, we have the current, we have everything. Now, if you take a look, where does the 6 come from? This 6 come from 3 plus 3. 3 plus 3 in series relationship, so then they share the same current. How much? 0.67. So we come over here, you're going to write 0.67. 0.67 what? Amps. And 0.67 amps. Okay, now if we have to write the voltage, of course we can write the voltage. Voltage is what? 2 volt, and this is also 2 volt. Okay, now let's come over here. How much current over here? 0.67. Current 0.67. Current. How much current over here? 2 amps. How much current over here? 2 amps. How much voltage over here? 60 volt. How much voltage over here? Of course, 20 volt. How much voltage over here? 4 volt. How much voltage over here? Of course, 4 volt. Now we have everything. We have voltage, we have resistance, we have current, voltage, resistance, current, voltage, resistance, current, resistance, voltage, voltage, resistance, current, and then resistance, current, voltage. Good. Now, if I ask you what, I put an ammeter over here and ask you what will this ammeter read, then you know that this is the part of the Arduino because I asked you exactly the same question because that was the snapshot. What was the snapshot? This 2 junction was the snapshot. Now you realize that current enter is 2A, 0.67 plus what is 2A, 1.33. Okay, now you know what that one came from. Is just a snapshot of a circuit. In this case, complex circuit. Now, if I ask you this one, what the ammeter will read here, then you of course going to say current entering is 1.33, then current exiting 0.67, then that must be 0.63, 0.66 rather. Okay. All right. So hopefully you understood this problem. Let's make one last problem to drive the Kirchhoff's law home. So Kirchhoff's law tells us that the current enter is equal to current exit. Okay, so let's make another problem. This problem would be, let's see, similar to the other one, 6 bulb. So 12, let's start here, 12 volt, 68 ohms, 5 ohms, 30 ohms, 5 ohms, 5 ohms, 12 ohms. Okay, all right, so I have 6 bulb. How many junction? I have 2 junction. Where do you see the junction? 4 junction. Junction 1, junction 2, junction 3, junction 4. So you see 4 junction. Okay, what are you going to do with this? You're going to convert this one to a circuit with, of course, 5 bulb. So 12 volt, 68 ohms. You have 5 ohms. You have 30 ohms. You have 12 ohms. You have 5 plus 5, which is 10 ohms. Okay, great. So still we have how many junction? 1, 2, 3, 4 junction. We're gonna try to make sure that we have a 0 junction, and that is what we call simple circuit. Simple circuit has a 0 junction. Okay, now if we convert this one to let's say 12 volt is over here 68 ohms, over here is 12 ohms, and of course we're going to add them up. 5, this is going to give us 3 ohms. Okay, now how many junction this one has? Well, this one has 0 junction, but this one doesn't have 1 resistor. So we're going to turn it to 1 resistor, and that would be our simple circuit. So 12 volt, if we add them up, this is 83 ohms. Okay, now let's find the current. Current is, of course, 12 divided by 83, which is 0.14 amps. 83 came from, of course, 68 plus 12, which is 80, plus 3, which is, of course, 83. And they are in series relationship. What is true for series relationship? Current is the same. How much is the current? 0.14. So we're going to write 0.14 amps, 0.14 amps, 0.14 amps. Okay, if we want, we can write voltage. Why not? This times this is the voltage, so it's 9.8. This time this is the voltage, so this is 0.4. This time this is the voltage, so this is 1.7. Okay, now where does this 3 come from? Don't forget this 3 comes from 5 plus 30 plus 10. Okay, they are in parallel relationship. What is true for parallel relationship is has the same voltage. How much is this? 0.4. So you're going to write 0.4, 0.4, 0.4. Okay, good. Now, we know the voltage, so we know the current. How much current over here? So this is 0.04 current. How much is this one? 0.01. Okay, how do you know? 0.4 divided by 30, 0.5 divided by 0.4 divided by 5, which is 0.08. Okay, good. And this one we already know, 0.14. This one we already know, 0.14. And the amps. And this is 9.8. And this is, of course, 1.7. Okay, now 10 came from 5 plus 5, and 5 plus 5 in series relationship. So we must acknowledge that in series, current is same. So we're going to write 0.04. So this must be 0.04. So 0.04. Okay, now if we know the current and if we know the resistance, we know the voltage. What is the voltage over here? Let's not write voltage, we don't need that. This one is 0.01 amps. This one is 0.08 amps. This one is 0.14 amps. This one is, of course, 0.14 amps. Now, if you notice over here, if I ask you what this one will read, then you have to tell us what this one will read, 0.06. What is that? Because the current entering is 0.14 and then current exiting is 0.08 plus 0.06, and that is 0.14. Now you're probably going to ask, what happened? Isn't it this one supposed to be 0.04? And why then this one is 0.05? Why this is 0.05? Okay, 0. Is entering 0.06 and exiting 0.01, so this is supposed to be 0.05, but instead it has to be 0.04. Why? Because Kirchhoff's law. Because due to rounding error, due to rounding, we lost some information. Okay, yeah. Let's continue with our Kirchhoff's current law. Okay. Let's give you a similar problem. I'm going to give you 30 volt. I'm going to give you 2 bulb. I'm going to call R1 is how much? Let's say R1 is 20 ohms. R2, I'm not going to give you anything. And I'm going to also tell you this 2 amps current. Okay, the current is 2 amps. Okay, so what I want you to do is following. I want you to find the resistance at R1, R2, of course, the equivalent. I want you to find the current. I want you to find the voltage. I want you to find the power. The easiest thing is the voltage. What is the voltage over here? 30. Why? Because they are in parallel relationship. You try to take the advantage. Okay. So you know the voltage. You know everything, right? This is you know the current. So the current is 30 divided by 20. So 30 divided by 20 is 1.5. So current is 1.5. Okay. Total current is 2. 2 minus 1.5 is 0.5. So 1.5, 0.5 is 2. Total current is 2, and of course. Okay, now we're going to find the resistance. What is the resistance over here? Resistance over here is 20. What is the resistance over here? 60. How is that? 30 divided by 0.5, which is 60. 20 plus 60 is 15. Okay, so equivalent resistance is 15. Now the power is 30 times 1.5 is 45. Of course, 30 times 0.5 is 15. So total power is 60. Okay, let's continue with one more problem before we close for the day. This one I want you to pay attention because we want to discover something. Okay, so I'm going to start our conversation with something like this. We usually start with resistance, but this time I'm going to give you 3 bulbs and I'm not going to give you resistance. I'm going to instead give you something else. I'm going to say this is 40 watt. This is 60 watt. And this is 100 watt. Okay, I have how many bulbs? 3 bulbs. One bulb is 40. The second bulb is 60. The third bulb is, of course, 100. So third bulb is brightest. Okay, what I want you to do, I want you to do a few things. I want you to, okay, before you prove that, I want you to think about this. If I remove this one, right? If I remove this one, this is called R2 or bulb number 2. So this is bulb 2, this is bulb 1, and this is bulb 3. Okay, if I remove bulb 2, would the bulb 3 be less bright? No, absolutely not. It is going to be the same bright, even if you remove bulb number 2. Okay, would anything at bulb 3 changes? No, nothing at bulb 3 changes. What do I mean? If I remove, right? Remove what? The bulb number 2. This is 100 watt. I completely remove bulb number 2. So if I do remove bulb number 2, what do I see? I see there will be nothing changes. This information and that information will be the same. Let's discover it. Okay, so let's clean it up. Okay. All right, so voltage 120, 120, 120. Oh, so what gonna be the changing? Three things gonna be changing: total current, total power, and equivalent resistance. Okay, so you're gonna discover it. However, this one and this one would be exactly the same. Okay. All right, so now let's find the current. So what is the current over here? The current would be 120, 40 divided by 120. So 40 divided by 120 would be 0.33. 0.33 is the current. Okay. 60 divided by 120, which is 0.5. 100 divided by 120 is going to be 0.83. Is the current. Let's see, the current would be the same. So this is 120. This is 120. So the current would be, of course, the same, 0.33. The current would be the same, of course, 0.83. Okay, now let's see the resistance. What is the resistance over here? 363 ohms, 240 ohms, 144 ohms. Okay, good. Okay, how do I get that? So 144, how did I get that? So VIR. So V, which is 120, I, which is 0.83. All right, and I believe that's 144. Okay, you can double check. Anyway, let's continue. Okay, so over here is 144 ohms, and what is it? 363 ohms. You see, information at location 1 and information at location 1 are the same. Information at location 2, or rather here, and information location here are the same. Although I remove the bulb number 2. So what effect they may have? They have this effect. So this is R. So this is R1. R1 is what? 363. R2 is what? 240. R3 is what? 144. Okay. So what is R? R equivalence is 72 or 71. Okay. Voltage 120, 120, 120, 120. Current. Okay. The current is, you see 0.33, you see 0.05, 0.50, and you see 0.83. Okay, so you have 6, and you have 8, So 1.66. All right. So now let's do this one. This is R. What is R1? R1 is 363. What is R2? R2 is 144. What is R? Equivalence. Oh, okay, they say it's 100. Voltage. Well, voltage, total voltage is going to be the same because it's parallel circuit. However, the total current will be the same? No. So the equivalence resistance are not the same. Check. Total current 0.33, 0.83, 36. All right, so this is not the same. Now what remains? Remain is power. Okay, so what is the total power over here? So let's do the power over here. Total power, you have 40, 60, 100, 200. Power 40 and 100. Total power is 140 and total power is 200. So these three things would be the different. However, information over here is exactly same as information over here, and information over here exactly same as information over there, although I remove the bulb number 2. The last thing probably I'm going to do is touching on static electricity, one of the small problem. Maybe two of the small problems. Okay, two of the small problems. Okay, the first problem is very simple. So let's say I have a sphere A and I have a sphere B. The sphere A has a charge -4 microcoulomb. Sphere B has a charge -8 microcoulomb. This is scenario 1. Scenario 2, I put them together, A and B. Scenario 3, I separate A. How much charge it has? Okay, it has -6 microcoulomb. Okay, if I ask you what is the excess electron over here, this is the charge. If I ask you what is the excess electron over here, how can you find? Come on, you want to say Q over E. What is Q? -6 times 10 raised to -19 coulomb. This is -6 times 10 raised to -19 coulomb. Divided by E. What is E? -1.6 times 10 raised to. This is -6. This is -6. Microcoulomb is -6. This is -19. Okay. Coulomb. Coulomb cancel. Minus cancel. So N is equal to 3.8 times 10 raised to 13. Okay, last thing, I'm going to just touch on this idea. The two plate, let's say you have two plates, and the acceleration between the two plates always constant. Why is that? Because the distance is negligible. So this is, let's say, positive plate, and this is negative plate. Okay. And the distance between positive and negative is very small. Distance is, let's say, 10 centimeters. Very small. So the acceleration is constant. So let's say there is an electron, right? The electron, so the field is, of course, this is the field. The force is, of course, this is the force. The field is constant. Why is that? Because acceleration is constant. The force is constant. Why is that? Because acceleration is constant. Okay. It's just like this one. This is Earth. This is a small mass. G is constant. Why? Because the distance is pretty small. I don't know. You say 100 meters above the ground or 200 meters above the ground. Of course, right here, G is 9.8. Right here is, I don't know, 9.7777. but we're going to say they are the same. 9.7777 is equal to 9.8 because the distance is small. Over here, we're going to say the distance is small because why? 10 centimeter or 20 centimeter or even 10 meter. Okay, we're going to ignore the small small changes in acceleration. So you're going to say acceleration is constant. Okay. So now to find the electric field is very easy. If I say the force is, I don't know, 10 Newton, I don't know, let's say not 10 Newton, let's say, yeah, 10 Newton. So what is the electric field? Electric field is F over Q. F is 10 Newton and Q is 1.6 times 10 raised to negative 19 Coulomb. All right. Let's not make it 10. Let's make it 1.6 Newton. 1.6 Newton. So this is 1 times 10 raised to 19 Newton over Coulomb. All right. So that's the force. Okay. All right. So I'm going to stop here. If you have any question, if this video really helps you to understand the Kirchhoff's law, Kirchhoff's current law, write the comment below. Or if you have any question, write it in the comment box. I'll try to answer your question.